Professor Iain McGregor, welcome into the weeds, brother. It is an absolute pleasure and honour to finally have you on, mate.
I'm delighted to be here, Jeremy. I've been waiting for this moment for quite a long time.
Well, with trepidation. You are a professor, a psychopharmacologist, which is a great Scrabble score, I got to say, and a complex area of science, a neuroscientist. You've written hundreds of peer-reviewed papers, and in terms of cannabis, you are the director of the Lambert Initiative, which looks into cannabinoid therapeutics here at Sydney Uni in Australia.
Correct.
That's all correct.
That's all true.
It's
You've
all
done your
true.
homework.
I have done my homework. I've been practicing all of that. But all of that adds up to you being probably one of the world's leading experts in cannabis and its effect on our brains, why it does what it does. I'm just really interested to hear about what you've been doing in terms of your research, what you've been learning about cannabis, cannabinoids, cannabidiols, all the compounds, terpenes that make up cannabis. But I want to find out a bit about you because you're a fascinating guy. You're a fantastic public speaker, an amazing scientist. Why did you become a scientist? You were a musician in Edinburgh, availing yourself of copious quantities of hashish, I understand, and you decide that you're going to become a scientist. How did it come about? Why the curiosity? Why science?
Well, I think I'd take it back to my high school education, and Scotland was blessed and still is blessed with a wonderful education system, public education system. And I was fortunate enough to go to a high school, James Gillespie's High School in the centre of Edinburgh. And they had the most exceptional teachers. My geography teacher was an astonishing woman, Miss Dalgleish, who taught me all about Australia.
Miss Dalgleish.
Before I'd ever been to Australia, I felt like I'd been there several times because the level of detail that we learned about Australia, that was one of the reasons I ended up here, I think, was a Miss Dalgleish. We also had a wonderful chemistry teacher, Jim Fairhurst, who was very passionate about what he did, very hands-on. We were doing chemistry experiments all the time in the lab. He sent me to a fertilizer factory from a work experience, which put me off chemistry for life. But you can't win them all. And I also had an exceptional music teacher as well, Mr. Somerville. So between Mr. Fairhurst, Mr. Dalgleish, and Mr. Somerville, I think I got this astonishing education that stoked this love of science, this love of geography, and love of music as well. And then they just happened to have this scheme that I think only ran for 1 year to get underprivileged Scottish people to go to Oxford in England. So they sent a bus up and said, bring out your underprivileged Scottish students and we'll take them down to Oxford. So I went down there, got interviewed, and they offered me a place. And so I was then the beneficiary of but I probably didn't deserve academically to get into Oxford, but I was a beneficiary of what was an incredible education in experimental psychology and pharmacology, zoology and neuroscience. And that just, captivated my brain at that stage of my life. Was ready to absorb huge amounts of information. And it was an astonishing education and kind of set me up for a life in science. Having said that, once I left Oxford, I was somewhat exhausted, so I spent 3 years in the music industry. This was around about the time, the 80s, I guess, and there was some terrible music and some pretty good music going on in those days, and I was into synthesizers. I wrote a lot of songs and played in some bands that didn't go anywhere. And then by 1986, I didn't really know what I was going to do with myself. I'd failed in my mission to be a successful pop star. And so I fell back in my science, thought about Australia, met all these Australian backpackers in Edinburgh who were fantastically sunny, happy people who would give anything a go. And my Scottish comrades were much more dour and depressed, and we were living through the Thatcher era where everything was pretty miserable. So when the opportunity came up to do a PhD in Australia, I jumped at it, and then I never looked back.
So you did your degree at Oxford. Tell us about what you were learning. Tell us about neuroscience back then. What were you really looking into? Because it was emerging field. Like cannabis research was sort of unheard of. What sort of things were you looking at Oxford?
Well, I went into psychology primarily because I was a little bit bored with all the subjects that I'd learned at school. And I thought, I want to do something completely new. And my mum was a psychiatric social worker. Dad was a chaplain at the Royal Infirmary. And so we talked a lot about psychology and psychiatry and social work and people with problems and how best to address these issues. And I was fascinated by the human brain and mind as well. So that's why I chose psychology. But the version of psychology you learned at Oxford was very biological. So we were basically looking at brain and behavior most of the time and quite a bit of pharmacology as well. And at that stage, Oxford probably had the best minds in the world in behavioral neuroscience and psychopharmacology.
What is pharmacology? What is psychopharmacology for kids playing at home?
Yes, well, psychopharmacology is the study of the effects of drugs on the mind and behavior. Pharmacology, obviously, the scientific study of drugs. And then there's neuropsychopharmacology, which adds this additional layer where you're trying to understand not only what drugs do to the brain and behavior, but kind of at a synaptic or receptor level as well. So you're going right down to the level of the individual neuron and looking at the electrochemical processes that alter brain function when you take a drug. And things got very interesting with cannabinoids in the late 80s and early 90s because we suddenly discovered what's known as a cannabinoid receptor. We realized
the endocannabinoid system,
and
our own cannabinoid production system.
Exactly, that's right. So how THC worked on the brain was a huge mystery for many, many years. I mean, obviously discovered by Mishulam in the 60s, but it was really only in the late 80s and early 90s that we realized that THC was doing something highly specific in the brain, that there was a receptor there, a CB1 receptor, and THC could fit into that like a key going into a lock and have this astonishing effect on brain function. The other thing that we realized pretty quickly was that the brain was absolutely festooned with these CB1 receptors that were all over the place. They were on just about every neuron, with the exception of the brain stem. So all your kind of cardiovascular and respiratory stuff, the basic stuff that keeps the machine ticking over, relatively unaffected by CB1 and THC. But in the limbic system, where emotions are governed, in the cortex, where we have our higher order planning and cognitive function, CB1 receptors galore. In the hippocampus, tons of CB1 receptors, hence the influence on memory. And then down in the hypothalamus, where things like appetite and sexual behavior are governed, again, real hotspots of CB1 receptors. So we could kind of piece together all that information, the distribution of CB1 receptors in the brain, and really start to understand functionally how THC was having an effect. And this was so new and so exciting in the 90s. I realized that I wanted to be part of that story and do lots of research in that area.
So you came to Australia, and did you straight away get into cannabinoid research, like as part of your PhD, or was that a focus when you came here?
No, the PhD was kind of a little bit pre the cannabinoid breakthroughs, and I ended up working with quite a small department in Sydney Uni devoted to behavioral neuroscience. And believe it or not, I started off doing this kind of quite strange experimentation, which I have mixed feelings about now, where we were sticking electrodes into the brains of rats and giving them an opportunity to press a lever to stimulate their own brains. And under these conditions, rats will often lever press compulsively if you put the electrode in the reward centers of the brain. And it's used kind of as a tool to understand addictive behaviors. And again, that kind of fed into my interest in drugs and drug addiction. Back in Edinburgh, I'd had a lot of friends who'd had troubles with drugs, with addiction. I lost one of my closest friends, actually, when a drug deal went wrong in Morocco that he was involved in. And this sort of had a profound effect on me in terms of trying to understand addictive processes, not only the benefits of drugs, but the drawbacks and the adverse effects. So the self-stimulation work was kind of fascinating because you had this like insane paradigm where you could interrogate the reward circuits of the brain and you could create addiction just by specifically stimulating little circuits within the brain. So it was an incredible tool to unlock addiction processes. However, I was always a little bit uncomfortable with the animal research and the ethical components, and I used to have quite a difficult time at night going home and thinking about the animals that we were doing surgeries on. And I still have that dilemma to a certain extent even today, because we continue with some animal research at the Lambert Initiative, where it really is only the only tool available to find out a particular bit of knowledge, but we do try and minimize that as much as possible.
Wow. So when did cannabis become an area of like a focus for you? When did you start moving into that field of research?
Well, I was interested in these CB1 receptors, and I remember at that time there was a special drug that only Pfizer made, and it was called CP55940. And it was a very selective and potent agonist at these CB1 receptors, but its effects were about 100 times stronger than THC. So I wrote a letter back in the days where you still sent letters to Pfizer in Groton, Connecticut, and said, dear Mr. Pfizer, could I have some? Could you please
writing to the Pope?
Yeah. Could you please furnish me with some CP55940? And expected that they'd just laugh and throw it in the bin, but within a few weeks, actually, I think a gram of the stuff arrived.
Really?
In the post, yes.
Oh, note that down. Have they got a catalogue? What was that? CP 100 times?
CB55940. So that enabled us to really probe these CB1 receptors in a way that wasn't so easy with THC. It was actually really hard to get hold of THC for research purposes back then as well. And the other thing that was true in terms of cannabinoid research was that it was only possible to really get research funding if you were showing that cannabis was doing something bad. So I had my suspicions that there was all these therapeutic benefits associated with cannabis, but at that stage, I had to write grants on things like what stimulation of CB1 receptors does to adolescent development and so on. So we had quite a lengthy, quite well-funded research program on cannabis-related harms, and it mostly involved giving THC and CP55940 and other tool compounds to baby rats and adolescent rats and grown-up rats as well. But that was quite interesting because
I think I saw one of your TEDx talks where you said that if there's an adverse impact in adolescent rats from THC, that really that probably will be replicated in later life. You can really see if you didn't like cannabis and it had an adverse impact on you as a 16 or 17-year-old, then and you don't try it again, and then you have it again when you're 35, it may well have the same effect on you.
Yes, that's right. I mean, we did these experiments that were really quite interesting because rats have an adolescence that only lasts about 3 weeks or so.
Oh.
Yeah, I do have a daughter who's now grown up, but I wished her adolescence had only lasted 3 weeks in some ways. Yeah, so you have that little window where the brain's still furiously developing and behaviors emerging, and sexual precocity is arriving, and so it's a really interesting little window. And so we could give THC during adolescence and then see what the long-term effects were in adulthood. And one of the things that we found out immediately was that older rats didn't like THC very much, or CP55940, or any cannabinoid, but the adolescent rats loved it. So it was this kind of developmental window where THC was a pleasurable thing for rats. But if their first experience of it was when they were 50 years old, they didn't like it nearly as much as the adolescent rats. But we did find some warning signs that, if a lot of THC was given during adolescence, the rats would grow up into adults that were marginally less sociable and maybe a little bit less cognitively skilled. They were all fairly marginal effects. And then we tied that to brain changes that we were able to interrogate using high-end neuroscience.
That's fascinating. Let's wind back a bit. CB1 receptors in the brain. Why are they there? This is a chicken and egg like thing. Why, like from an evolutionary standpoint, why do we have these receptors in our brain? Is it because we produce our own cannabinoids, or is it because we've essentially developed with cannabis as part of our like consuming cannabis for millennia or hundreds of thousands of years? Why are those receptors there?
Well, that's a nice, easy question, Jeremy. Thanks for that one. No, it's an area that we often ponder, and you're right. You can go back 400 million years and find CB1 receptors in bony fish. We work with zebrafish quite a lot in our research, and they have CB1 receptors too. Our best guess at the moment is that the role of CB1 receptors is to restore equilibrium. And you're right, there's these specialized lipid messengers called endocannabinoids, the main ones being anandamide and 2-AG. And what we see is that anandamide and 2-AG are often released when the brain's under some kind of stress, and they flow back to CB1 receptors and manage to dampen down hyperexcitability. So one of the best illustrations is actually in epilepsy, where you've got abnormal firing of neurons. And so you've got these neurons that are basically participating in an electrical firestorm within the brain, an epileptic seizure. This causes a massive release of endocannabinoids. And they go back to CB1 receptors on these hyperexcitable neurons that act a little bit like thermostats and are able to dial down that hyperexcitability. So,
where are they produced in the body? Where do they come from in the body? Are they in? Is it in the brain, or where is it that they?
Yes, well, the endocannabinoids are produced in the brain on demand. So
Amazing.
So normally with other neurotransmitters like dopamine and serotonin, they're kind of pre-packaged within the neuron and released whenever they're needed. The neuron actually synthesizes 2-AG and anandamide just whenever it needs it. So it's like, bang, there it is. There's no pre-packaging and so on. So you get this incredible, what I call a homeostatic process with endocannabinoids, where when the brain is out of balance, you get this massive release. And that causes the brain to rebalance and restore equilibrium.
And the receptors across the brain, all parts of the brain.
Yeah, they're everywhere, but they're often located on what we call presynaptic terminals, which is where neurotransmitters are being released from. And so when endocannabinoids bind to CB1 receptors on these presynaptic terminals, it will influence the release of other neurotransmitters that may be causing that hyperexcitation. So it's almost like, closing the dam shut so the water stops flowing when the CB1 receptor is stimulated. So they're the kind of master regulators, if you like, of the brain. But that's horribly simplistic in as much as there's many other lipid molecules, not just anandamide 2-AG. There's probably another 50 endocannabinoid-like lipids within the brain. And it's not just CB1 receptors. Our endocannabinoids bind to maybe 20 different types of receptors. So you end up with this incredible complexity. And I was saying the other day, if someone ever says to you they understand the endocannabinoid system, they're lying, because the level of complexity is so great. It's like this fantastically complex orchestra that is working at a millisecond resolution to guide brain function and brain equilibrium.
In the milliseconds to billions of neurons in your brain, self-regulating everything from your memory to, like how you're perceiving the world and what you're thinking about. That is just unbelievable. And then by luck, is it that THC exists and just fits in? Is it like, tell us about your understanding, because you would have to have looked back at where cannabis came from. Like, have we bred up cannabis to have more cannabinoids in it, the THC in it? Where did cannabis come from? Why did this plant produce delta-9 tetrahydrocannabinol in the first place? And why have we availed ourselves of it, in your view?
It's a great question as well. We can only sort of hypothesize about that one too. But obviously, there's a whole family of drugs that are both poisons and pleasure potions, and they come from plants. So about 70%.
Because I have heard it hypothesized that THC was probably a defense mechanism
Yes.
for the plant.
Yes,
it was
that's right.
it was a resinous. It probably kept insects away, and also maybe some like dinosaur or herbivore comes through, eats it, has a really bad trip, and says is unwell, has to lie down under a tree, and says, "I won't do that again." But Homo sapien or whoever it was, Homo erectus or whatever, comes along, eats it, and says, "Wow, I'm feeling relaxed, and this mango tastes a lot better."
Yeah, it's what we call the stoned goat hypothesis. That the goat comes along, nibbles on the plant, thinks, "Oh, I feel a bit weird. I'm going to lie down under that tree, and I'm not going to eat that bloody plant ever again." And the same would apply to tobacco plants, to coca leaves, to opium poppies, all the rest of it. So there's a lot of theory in ethnobotany around such matters. Magic mushrooms being another example as well. So it could be that, but it could also be that there's a symbiotic relationship between the plant and the human species, in as much as if you think of cannabis sativa and the amount of the Earth's surface that is devoted to growing it, it's been fantastically successful. And so
this is the Yuval Noah Harari hypothesis that wheat is farming us.
Yes, that's right.
It's farming us. We think we're farming the plant, but the plant is just going, "Hey, these guys are useful. Make yourself, more nutritious, and the grain's a bit bigger, and this monkey's going to spread you all around the world."
Absolutely. So we're kind of sitting at the same table in a way, and benefiting in different ways from that symbiotic relationship. I think both might be true to a certain extent. I mean, in the old days, probably the stoned goat was driving things more than the Harari hypothesis that, where we have this symbiosis between us. But I think it's fascinating to ponder these very deep philosophical issues about the relationship between drugs and human beings, and how we change each other. Because we're changing the cannabis plant as well. If you look at the potency of THC just over the last 30 years, in your typical cannabis, it's gone from 4% to 20% in a short space of time. So we're changing the plant, and the plant is changing us.
And there seems to be, in terms of ethnobotany, this distinction between cannabis sativa, which may have been more of an industrial type use, your hemp type, and cannabis indicas, north of the Himalayas, that was probably selected more for its, probably for seed and food, but also for its psychoactive impacts as well.
Yes, maybe a long time ago, but the scientific position these days is that the indica sativa distinction is nonsense. And, if you go to a dispensary in the USA and buy 25 indica and 25 sativa products, allegedly, and do the chemical analysis of them, you'll find they're almost identical.
Really?
Yes.
Okay.
So that particular myth has been quite well busted, actually, over the last little while. But it, never let the facts get in the way of
some good marketing.
Exactly. But beware of that. If someone says, "Well, this is a beautiful indica strain that will help you relax and sleep tonight, and this sativa one will help you get ready for the day and feel energized and full of fun," if we do the analysis of these two things, most likely they'll be exactly the same.
Probably in the future, we will get a biochemical analysis of what it is in terms of your cannabinoids, your cannabidiols, the entourage, the terpenes, everything. It'll become pretty sophisticated. Before I get on to where we are, the state of the world in terms of cannabis research, was there a time when we did look at cannabis as a medicine before there's a renaissance going on? We could call it a renaissance in terms of our understanding of cannabis, our use of cannabis, our research into cannabis right now. But was there a time, previously when people were accepted cannabis as a medicine, were doing research into it, or is this the first time it's really happened?
Well, yes, I mean, as a medicine, it's almost as old as we are. I'm pretty sure, there's all sorts of archaeological evidence of use, even 3,000 years BC. So there's no doubt about that. In the 1950s in Australia, you could go to a pharmacy and get cannabis tinctures quite easily.
But what about the 19th century? Because that was a much more liberal time. You could buy cocaine from the pharmacy. There wasn't this sort of moralizing about all these compounds. People just used what was available.
Absolutely.
And was it like was there widespread use then?
Yes, absolutely. And my father, and he suffered from asthma, and he had this wonderful medicine called Hinksman's asthma reliever, and a special pipe that he would inhale this stuff with. And of course, the active ingredient, I don't have to tell you, is a fantastic bronchodilator THC.
Really?
Yeah.
Fantastic.
So that was more 50s. But yeah, in answer to your question, certainly in the 19th century and before, it was a very well recognized medicine, as well as a great source of fiber and food as well. I mean, you go back to George Washington, the founding fathers, it was actually mandated, it was compulsory to grow hemp. You get into trouble for not growing it.
Yeah, Australia was founded as a hemp colony.
I know, that's right.
Joseph Banks said, "Look, we'll remast our ships and grow hemp and refit them with sail and rope and cordage and the rest."
And that was quite an insight, because it continues to grow very well here even to this day.
Yes, it does. In the Hunter, they had an eradication program in the 60s. They went out, they had to go into the Hunter Valley to try and eradicate it. It was going all down the Hunter River. And the hippies would go out, and I think it was hemp. It was like hermaphroditic, pretty coarse, low THC strains. But they had to go out and eradicate it when they discovered that there was thousands of hectares of it just growing wild. So it could be a pest. Now, like the early 2000s, there's a renaissance. There's a review of cannabis, and a massive amount of attention put onto its potential therapeutic benefits. How did that come about? Why did it come about? And how did you get involved?
Well, I think it was really inevitable that the war on drugs would run its course, and this, what I think of as a historical anomaly with the demonization of cannabis, that would evaporate, and we'd go back to understanding it as a great tool, a great piece of medicine, a great help on many different levels for the human species. Personally, I think one of the major things that happened was the formation of a company called GW Farm in the UK. And they got a license from the UK government to grow cannabis before it was actually that fashionable to do so. And we just got chatting to them at various conferences, because I was going to a lot of cannabis-based scientific meetings where I was parading various studies showing that cannabis was bad for adolescent rats. And by that stage, we were also looking with some clinical colleagues, particularly Professor Nick Lantzeris at the Langton Clinic here in Sydney. We were looking at issues of people who were trying to get off cannabis. And so we were looking for cannabis substitution strategies. So could you get someone to stop smoking joints and maybe take their cannabis in a less harmful way, like an oral spray? So anyway, GW had developed a product called Sativex, which was 1 part THC, 1 part CBD oral spray that's supposed to be absorbed sublingually. And so we got interested in that, and we got talking to them, and they were happy to fund a trial or help us get a trial established, where we got people who were trying to give up cannabis to use their oral spray. The main application for Sativex was actually multiple sclerosis and severe muscle spasticity and pain that accompanies a lot of people that have MS. And they'd already shown in clinical trials that Sativex was quite effective. So we actually did the first ever clinical trial with a cannabis product here in Sydney with Nick Lantzeris and the team, and gave Sativex to people who were trying to come off cannabis, and found that it quite effectively substituted for smoked cannabis. That that's maybe not a surprise these days, but back in 2013, 2014, that was quite innovative. And meanwhile, GW were making all these waves with their product, and people, I mean, the evidence they developed around multiple sclerosis was fantastic and showed the efficacy of that particular medication. And they also funded a lot of research, a lot of basic research into the minor cannabinoids, things like, CBD, CBN, CBDV, CBG. And so I visited them quite often and spoke to them a lot. They were kind enough to supply us for our research program with a lot of these very rare minor phytocannabinoids, things like CBN and CBG. And that allowed us to start researching these minor phytocannabinoids, and also to do some interesting research where we looked at the components within street cannabis in Australia. So suddenly there was a kind of a little flip around about 2010, I guess, where we went from thinking, oh, cannabis is bad for the adolescent brain and it might cause schizophrenia in vulnerable individuals and people get into trouble with it and we have to help them get off cannabis, to, wait a minute, this is a treasure trove of really interesting molecules, and the therapeutic potential here is absolutely boundless.
So talk to us about those molecules, because, oils ain't oils. There's THC, which everyone has been the focus because of its psychoactive effects. But what we're learning is that there are just the armada of these minor phytocannabinoids, or cannabidiols, did you say? Is it cannabinoids?
Phytocannabinoids, yeah.
Phytocannabinoids. Tell us about the difference between some of them and what some of them do individually and do together.
Well, I think the first point to make, and this goes back to a real fun experiment we did in 2012, 2013. There was a woman at the National Drug and Alcohol Research Centre called Wendy Swift, who'd been trying for years and years and years to get permission to work with the police to analyze street cannabis to see what was in it in terms of THC, CBD, and all the minor phytocannabinoids as well. And bless her, I think she'd been at it for about 10 years, and the red tape was up to here in terms of how much that she had to do. And eventually, with the help of GW Farm and with Wendy, we were able to persuade the New South Wales Police to let us do a study to look at the components within street seized cannabis. So we had this hilarious situation.
So you had to supply it, get it from the police.
Yes.
You had to go through to their warehouse and go, some of this, some of that.
Well, both that, but we also had police arriving at the lab up there in Camperdown on main campus with huge bags of weed. So it
wouldn't have been the first time.
The police would arrive with this poly bag that I swear had half a ton of weed in it. And what we learned was actually they were really glad to get rid of it because it was cluttering up their evidence rooms and they couldn't be bothered. They didn't have space for other exhibits in the stations. So how much do you want? We'll give you 2 tons if you want it. But we ended up with more than 200 different samples. And in terms of the minor phytocannabinoids, it was a little bit boring. I mean, the answer was really that your average street cannabis in New South Wales had about 14% THC. This was back in 2013. Hardly any CBD at all. And then a tiny little smattering of CBG, CBGA, other CBN, CBC, other minors. So that kind of got us into minors. And then GW were interesting because they started playing around with the genetic code of the cannabis plant and were able to get particular strains that overexpress things like CBG relative to THC. And they also had hemp strains, which traditionally are very enriched in CBD, but very low in THC. So there's 2 main cultivars, I guess. There's the hempy ones, which have a lot of CBD and don't get you at all intoxicated, very useful for food and fiber and for CBD. And then there's your more sinsemilla, you might call it, or marijuana, where there's high levels of THC, not very much CBD, and a smattering of minor phytocannabinoids, but really at concentrations are unlikely to have major physiological or pharmacological effects.
So that then begs the question, well, what if you start mixing these together? So is that like an area that began to emerge? Like what if we include CBD, high levels of CBD with our THC? What happens?
Well, that's right. I mean, side effects was interesting from that perspective because they quite deliberately had THC one part to CBD one part. So that 1-to-1 ratio. And I remember asking GW about this and saying, why do you do that? He said, well, we believe that if you add CBD, it takes a kind of paranoid, anxious edge off the THC experience. What we've learned since then is that's probably nonsense because CBD tends to need to be dosed at a much higher level than THC. So an effective dose of THC in someone that doesn't use a lot of cannabis is maybe 10 milligrams or 20 milligrams of THC, either in an oil or smoked. With CBD, you have to be up probably at 300 or above.
Wow.
In order to get noticeable beneficial therapeutic effects. So we kind of called out GW a little bit on that one, and we did some research where we kind of showed the dosing that's necessary with CBD. So for example, the clinical trials that we run at the moment with CBD, and there's quite a lot of them, we're dosing often up at 800 or 1,000 milligrams, whereas in a THC trial, we'll dose at 10, 20, 30. So that dose differential is definitely the case. There is an interaction between THC and CBD, but it's not what was always assumed, that CBD would take the edge of THC anxiety. In fact, if you take a lot of CBD, say 300, with a small amount of THC, say 10, the CBD actually interferes with the metabolism of the THC. So you end up getting more stoned if you've got CBD on board, and you can kind of get a doubling of the therapeutic concentrations of THC and 11-hydroxy-THC, its active metabolite, if you've also got CBD on board. So it's not what GW thought. In fact, it's the opposite when you go up to higher levels of CBD.
Fascinating. And this is emerging. So you're popping all these myths and all these preconceptions about how this amazing plant and these amazing compounds work within our brain and work together. And you're doing it through clinical trials, through research, through very, very serious science. And that science is happening at the Lambert Initiative. You're the academic director there.
Correct.
And it is an amazing facility in the heart of Sydney Uni, in the heart of Sydney. How did it come to be? How did the Lambert Initiative, which you're heading up, come to be? Tell us about that period in the sort of 2015 where it really kicked off.
Yes, I mean, it's an incredible story, and it's kind of chance and serendipity and generosity all kind of mixed together. And there's a woman who you'll know very well, and that's Lucy Haslam, who at that time was living up in Tamworth. This would have been 2014. And I got invited by the ABC, I think, to go on the 7:30 report to talk about this emerging area of medicinal cannabis. And I got interviewed in the lab, and I said something like, if patients need it, then there's no reason to deny them access. We need to wake up to the science and know that there's benefits in the plant. And so I got this random email the next day from this woman, Lucy Haslam, who said, my 20-something son, Dan, has got stage 4 bowel cancer. He's dying, and the only thing that helps him is cannabis. And we're in a situation where we're having to go out in Tamworth, in this country town, and try and score weed. And my husband just happens to be the local drug squad detective, just to add a little bit of spice to that situation. And I've got Mike Baird's ear, the then Premier of New South Wales, and we're organising a symposium to get everyone in the room to talk about medicinal cannabis. I saw you on the 7:30 report. Would you like to come up and talk? And I said, great, love to. And so I got a couple of my colleagues, Nick Lynn-Serres and Dave Alsop and Tom Arkell. The four of us went up for a weekend in Tamworth, and it was the most amazing experience. And we talked about the research we were doing and the potential for cannabis as a medicine. We met a lot of patients. We met a lot of people who felt very strongly about changing the laws. We met a lot of very colorful people from Mullumbimby and Nimbin and these sort of locations as well. So it was a fantastic meeting of minds. And in my talk, I said, wouldn't it be fantastic if we could fund a research center for medicinal cannabis in Australia? And there just happened to be this man in the audience, Michael Lambert, who's the father of Caitlin Lambert, a little girl who had severe intractable epilepsy. And Michael was illegally importing a product from Denmark, which was a cannabis-based product, mostly enriched in CBD, that was having this phenomenal effect on Caitlin's health. She was going from having hundreds of seizures a week to having no seizures, and she was communicative and essentially looking much more like just a normal 3-year-old girl. And so we thought nothing much of it. We talked to Michael a little bit, and then a few weeks later, he contacted Dave Alsop, my colleague, and said, I've been thinking about this research center idea, and you might want to meet my dad, Barry Lambert. He's a well-heeled individual, Caitlin's granddaughter, and his wife, Joy, Caitlin's grandmother. They'd like to talk to you about your centers. So we went up to Coleroy and met Barry and Joy, and had a long process of negotiation where eventually they gave this unprecedented gift of $33.7 million for a 10-year research program into medicinal cannabis. And in scientific terms, that was like winning the lottery, this huge amount of money. They basically gave us everything that we needed, everything that we asked for, and they did it almost without question. And it was just the most incredible story of love and compassion and generosity and a belief in science. And we remain incredibly grateful to the Lamberts for that opportunity, which we like to think we've managed to succeed quite well in terms of the way we've used these funds.
It's been profound and so impactful. How did the institution deal with it? Like a faculty looking specifically, an institute looking specifically at medicinal cannabis and cannabinoids and these other, where there's still a lot of stigma around. How did that institution deal with it? I mean, like, never look a gift horse in the mouth. There's a lot of money there, but was there any pushback from the institution itself?
Well, I remember a very wise friend of mine who's a clinical psychologist said to me at the time of the gift, this isn't going to be nearly as much fun as you think it's going to be. and these were very, very wise words. And she also said, your life is going to change hugely, which was also very wise. But Michael Spence, who was then the vice chancellor, saw the value in this, and he saw where it was coming from, and he forged quite a good relationship with the Lamberts. And so institutionally, we had our, top guy, the figurehead, very much on board. Unfortunately, universities are big, lumbering beasties that, take forever to make decisions, and they're not very good at sudden change. And so the first 2 or 3 years were incredibly frustrating. We didn't have labs. We had all this money. We had nowhere to do what we were trying to do. We had endless amounts of paperwork and forms, and just the handling of procuring cannabinoids, of establishing clinical trials, all of that stuff. We really had to teach the university how to manage it, and also to de-risk the whole issue of cannabis and cannabinoids, that it's not what you think it is. This is actually medicine and should be treated as such. But eventually by 2018, we had wonderful labs that you visited in the Brain and Mind Center. We had a pretty good team. Unfortunately, at that time, Dave Alsop, who was really instrumental in his relationship with Michael Lambert and ensnaring the gift, became very ill with esophageal cancer. And so just as we were getting ahead of steam up, we had that terrible blow with Dave's terminal illness, and we lost him in 2018, which was, it was like having your heart ripped out of the Lambert Initiative. He was the heart and soul of the place. So we had to regroup, and there's not a day that goes by where I still don't think about Dave, and his legacy lives on. A lot of the things that have reported recently in terms of successful clinical trials of cannabis products were things that Dave dreamed up way back in 2018, 2017, 2018.
Well, tell us about them. Tell us what are some of the things that are now concluding. What are we learning out of the initiative? What are some of the things that have been dreamt up? What have we learned?
Well, we ended up working in 3 different areas, roughly. One was completely unintentional. We had no intention of getting dragged into drug policy and politics, but we learned quite early in the piece that both Barry and Joy were indignant about the plight of patients, and they insisted that we use our science to show that medicinal cannabis worked and to highlight the plight of patients. And that sent us into areas like driving research, which was really interesting. Lots of surveys to kind of take the temperature of patient population to highlight all the difficulties they were having. A lot of Senate inquiries that we appeared in front of as well. We met more politicians than we probably wanted to. Sorry, Jeremy.
That's all right.
You're not one of them.
I've met more politicians than I've wanted to. Right.
So that was
Scientists are far more interesting and productive, let me tell you.
Thank you. So that was a policy side, which ended up being surprisingly rewarding, but hard work. And then,
But tell me, like, in terms of, like you said, that cannabis works. Like, works on what? Like, there's so many conditions. Like, there's a big long list of pretty serious ailments and illnesses that cannabis works on. Let's drill down into some of them. Like, how does cannabis work, and what does it work on? What are some of the sort of headlines where you've gone, wow, that is a big impact, and we've proved it?
Yeah, well, there's 4 or 5 trials that I'm particularly proud of, and there's a few more to report. But very early on, Dave got talking to people at the Lifehouse in Sydney, and there was a bit of a signal,
which is a cancer,
a fantastic centre
the O'Brien
for treating cancer. And so we got talking to oncologists there, and we still talk a lot to them. But one of the issues they confront is, maybe 30% of patients on chemotherapy have uncontrollable nausea and vomiting, and the existing prescription medications are not good enough to help them. So Dave helped design this trial with Peter Grimison, who's an oncologist there, very good researcher, where they gave capsules with THC and CBD to these patients who weren't benefiting from existing chemotherapeutic interventions. Found a fantastic therapeutic effect. I mean, it took probably 3 or 4 years to set up the trial and for it to report. But there was no doubt that patients given the capsules with THC and CBD in them vomited less, experienced far less nausea. And that's a huge success story. I mean, that gives the high-profile paper, which can change clinical practice all around the world. There we've got a well-controlled clinical trial, shows efficacy beyond the shadow of a doubt. You can now prescribe this with confidence to patients who have treatment-resistant chemotherapy-induced nausea and vomiting. That was one. A second one that Dave helped set up that again took several years to report, long after he died did we get the data, was severely anxious young people. And so we collaborated with Patrick McGorry and Paul Amminger, who are down at Origin in Melbourne, a leading international centre for research into youth mental health. And we asked the question, well, CBD seems to reduce anxiety, but you probably have to dose it pretty high. So we went up to a maximum of 800 milligrams of CBD and got basically more than 30 kids who were the most severe examples of treatment-resistant anxiety. So they'd been on antidepressants, didn't work. They had clinical psychology treatment, all the interventions, and we dosed them with 800 of CBD over 12 weeks. And 30 out of 31 of them got incredibly improved in terms of their anxiety. These were kids that couldn't get out of the house because of their anxiety. They couldn't go to school, couldn't go to uni. With 800 of CBD, their lives were transformed. All the measures, they were improved. Their own subjective feelings of anxiety, clinician-rated anxiety, clinician-rated depression, and social and occupational function. And that's transformed now into a much larger trial with the same intervention, which we'll report in the next year or two. But that was an incredible result. And we've also taken that information to run a current trial in severe anorexia nervosa with the same intervention, 800 of CBD, where we're getting young people as, girls as young as 12 who are saying that they no longer have an eating disorder when we put 800 of CBD in there. So another amazing win in youth mental health. I'll give you another couple if you want.
Yeah, please do. It's fascinating and really important information.
Another affliction that primarily affects young people is Tourette's syndrome. And so we worked with a psychiatrist up in Brisbane, Phil Mosley. And again, Dave made that contact back in 2017, 2018. He had the insight that THC in this case might do something amazing for tics. There were kind of little intimations of that in the literature if you looked hard enough, case studies and so on, but no one had done a rigorous clinical trial that was placebo controlled. And so we worked with Phil to design this trial, and we ran it, and proper crossover placebo controlled trial, and found that THC had this incredible effect in Tourette's syndrome with tics down about 40% when they were on the THC medication. And all that entails. I mean, if you've got severe tics, you don't want to go out in public.
Oh, incredibly debilitating.
We had a guy that couldn't even read a book because his tics were so bad that he couldn't hold the book long enough to be able to read it. And on THC, his life was transformed.
Amazing.
The tics disappeared. Again, gives the evidence to change clinical practice. It was a well enough designed study that it would give clinicians confidence that a capsule of THC would have this incredible effect. And I should hasten to add that there's next to no side effects. We were dosing at a level where these patients didn't feel stoned, they didn't feel intoxicated, they felt like they could go out and participate in the world without feeling, intoxicated. And so that was a huge win. And again, thanks to Dave Alsop, that it was his insight. And then another one I would mention, I mean, I could go on with quite a few, but
keep going. What about epilepsy? Like, what about that area? Because clearly that was the beginning of like the Lambert Initiative was, let's find out why CBD's working, and what did you find out about that?
Yeah, well, I mean, one of the ironies of the last 10 years was that we went in with a mission that was orientated around epilepsy. But to their credit, Barry and Joy didn't insist that we study cannabinoid effects in epilepsy. They said, study any condition where you think cannabinoids might be useful and might be successful. And so we were very grateful for that, because it turns out that running epilepsy trials is incredibly difficult, and particularly difficult if it involves children. So unfortunately, we're not at the stage where we've run any proper clinical trials of a cannabinoid product in children with epilepsy. The other factor was that in the meantime, GW Pharm had come up with Epidiolex, which is a CBD-based medicine that had been rolled out all around the globe. And, the transformation that occurred in Australia was quite phenomenal, in that in the early days, we met all these families like the Lamberts who had children with epilepsy who were essentially breaking the law to bring in products from overseas, or quite often making their own oils and tinctures in the backyard with unknown composition, unknown quality control. When Epidiolex came along, it quite rapidly ended up on the PBS in Australia as well. So suddenly these families that had kids with epilepsy could, not all of them, because you needed certain types of epilepsy, you had to tick certain boxes, but quite a few of them could then access a quality control prescription medicine. And that and they ran fantastic large trials in these populations. So that took the pressure off us to show that CBD was effective in epilepsy, and our work turned to exploring other minor phytocannabinoids, and also coming up with tweaks on cannabis molecules to come up with proprietary designed molecules that had strong anticonvulsant effects. So as of today, May 2025, we're sitting on 4 different families of brand new anticonvulsants that we've developed at the Lambert Initiative in our research.
These are man-made cannabinoids.
We call them cannabis inspired, and I'm jumping forward a little bit, but I was saying there's 3 things the Lambert Initiative did. We did policy, we did a lot of clinical trials, but we also had this kind of biotech thing happening where we were working really at the coalface of molecular biology and pharmacology and medicinal chemistry to create what I call cannabis-inspired molecules. So it's not THC, it's not CBD, it's not CBG, but we take that particular chemical structure, play around with it, to try and enhance its function as a medicine for particular treatment. So we have this CBD-inspired molecule, which we call Lambert Initiative 1140, LI 1140, and that's our lead epilepsy molecule. It ticks all the boxes in mouse models of epilepsy and zebrafish epilepsy, and we're hoping to get that to the clinic in the next 2 or 3 years. It's a very long path to get to the clinic, but we have that molecule, and we have 3 other families of anticonvulsants that we've developed as well. So it's, it's fantastic, because the 10-year plan was always to succeed on that level, to come up with new medicines. And we've done that with epilepsy, and we also have major discoveries for insomnia and also for lifespan extension. They're the 3 areas where we've got families.
Lifespan extension. Tell me about that, mate. Like you lived to 300. 800. Methuselah was just on the cones. Tell me the truth. Is that what happened?
Well, the first thing I'd note is that, the anti-cannabis brigade have always tried to pretend that it's killer cannabis, that, is going to destroy you. And so we, I've been in more debates, and I'd like to remember with anti-cannabis people, and particularly in the early days of Lambert Initiative. But one thing that stands out in the epidemiological literature is that people that use cannabis don't die any earlier than people that don't use cannabis. Which is quite astonishing in a way, because if you drill down beneath that, you'll find they're more likely to smoke tobacco, they're more likely to drink alcohol excessively and use other drugs.
Be musicians.
Well, that's right. Jazzers.
Oh my God.
Yeah, jazzer.
That'll end your life early, being a jazz musician. Yeah, right. That's fascinating.
Yeah, so that's the first observation. But we were lucky enough to hire a scientist, Zhizhen Wong, who works closely with my deputy director, Jonathan Arnold. And they basically started this new research program at Lambert Initiative looking at how cannabinoids influence both lifespan and health span. So it's one thing living to 150, but if you don't have your health, you're just miserable for half of those years. So we look at both the extent of life, but also the quality of life in terms of health. And this is a massive area of science at the moment. As you probably know, Peter Attia's Outlive was a New York Times bestseller, which is all about the science of longevity, and there's all sorts of celebrities that have various interventions. Anyway, we started where most people start, and that's with worms. So the accepted way of looking at longevity in the lab is to use a species of roundworm called C. elegans, and these guys live for 21 days. And so you can very easily, in quite a short experiment, see if your drug extends their lifespan or shortens it. And so we did a lot of screening of different cannabinoids with C. elegans, and we showed that CBD gave about a 20% increase in lifespan. That was a very interesting finding. THC, maybe not so much. But then we were able to isolate some other compounds from hemp, which I can't actually disclose what they are, which have astonishing lifespan extending effects. And then we played around with their chemical structures to come up with a molecule, which is LI 1113, which gives about a 43% extension of lifespan.
How does it do that? Does it enable cellular regeneration, or does it stop the onset of disease? How is it working?
Well, it's really interesting. I mean, the medicine is changing. So, the old model of medicine is very much wait till someone's got cancer or has a heart attack or gets dementia or type 2 diabetes.
Wait till you break down and then act.
And then we'll take you to the garage and see if we can fix you and
replace that bit.
More often or not, you can. It's the beginning of the end. So the next wave of medicine will be all about preventing the biology of aging. So there's these processes that happen at a cellular level where cells basically break down. They become what's called senescent. And senescent cells stop dividing, and they also secrete a bunch of nasty chemicals that can have really deleterious effects on neighboring cells. So if you can take out senescent cells and destroy them, then you increase the whole longevity of the organism and greatly improve the microenvironment for the remaining healthy cells. So the ways to achieve that in biochemical terms are still being debated and still being discovered. So it's more of what we call a phenotypic approach. We're not quite sure how these drugs work, but the animals that we treat have a phenotype of a much younger animal. And we can interrogate the biology of it and probably find out down the track exactly how that's happening. But at the moment, we know that we have a family of non-toxic cannabinoid-inspired molecules that are not only extending lifespan, but also nuking these senescent cells, taking them out. We can actually measure the destruction of senescence. And the nice thing is that they kind of specifically target the senescent cells without having any adverse effects on the healthy cells whatsoever. So this is a new area for us, but already we've just made some remarkable discoveries. And I think we probably have one of the best, what we call senolytic or senescence reducing compounds in the world today that is also extending lifespan.
Jeez, a fountain of youth. Hello, you heard it here first. Well, mate, when you're still alive in 2319, we'll know something's up. People don't know this, that Ian is actually 186. He's pretty good shape for that. He was born a long time ago. That's fascinating. Now, Parkinson's, like, are you doing any research on Parkinson's or any other of these, like dementia, some of these Alzheimer's, some of these degenerative diseases that are coming downrange, are killing more and more people as we live longer and longer? We're not dying of cardiovascular disease or cancer as much, but Alzheimer's is going to be one of the biggest killers in the world. Is there any research in these areas where cannabis is and cannabinoids are being effective?
Yes, well, I was talking to a great researcher at the University of Sydney, Anastasia Sureyev, who used to be with the Lambert Initiative and then joined our healthy aging clinic at the Brain and Mind Centre. And they have a fantastic resource, which is a whole collection of people 55 and over, where they've been collecting longitudinal data for a very long time. So they have this very rich database of people's medical histories, and they're going to continue to follow them as they become 60, 65, 70, 75. And we can actually run clinical trials in the healthy aging clinic with these people that have exceptionally detailed and rich medical histories and a whole bunch of biomarkers as well. So the plan with a couple of our senolytic compounds is to get a clinical trial organized there. Again, you're not kind of going straight for dementia because by then it's too late. What you're trying to do is protect people against dementia and cardiovascular disease and all the other nasties. So that trial is in the offing, and we have a cannabinoid that we believe we can get into a clinical trial very quickly. Because that's the other thing with novel molecular entities. If it's a brand new molecule that you've rustled up in the lab, you have an incredible burden of proof in terms of its safety. And you've got to do a huge amount of toxicity testing before you can take it into a clinical trial. And that can often take 5 or 10 years. Another area which is really interesting from
You're never experimenting on yourself, mate. One of these pioneering scientists, like, I've come up with a new cannabinoid. No. I don't want you to get yourself in trouble there.
Well, it's a very good question, and you look at someone like Alexander Shulgin, who's a pioneering psychonaut and wrote wonderful scientific treatises on tryptamines and phenethylamines, and he not only took everything that he synthesized himself, he tried it on his wife first. Which was, I guess that's one way of dealing with a safety issue. But yeah, I mean, there's a long and rich history of self-experimentation. But the other area in dementia that I think is worth flagging is the unbearable aggression and agitation that often accompanies dementia in elderly people, which is fantastically troubling for families and loved ones to deal with. And there's emerging evidence that THC might be quite useful in low doses in preventing that aggression. It was quite an interesting clinical trial done in the USA. But I also put in a plug for a company called Cannabis. Way back when I was having a bit of a sabbatical from cannabis, I worked on the hormone oxytocin, which has a very interesting effect on social behavior and helps mothers bond with their infants and has a whole bunch of interesting pro-social effects. One of the things I'm most proud of in my career was to link MDMA's effects, where people hug each other and fall in love instantly, to a massive surge of oxytocin in the brain. We did that back in 2009. But anyway, to cut a long story short, we stumbled into a molecule in 2010 which is now called KNX 100. And that's currently in phase 2 trials for agitation and dementia. So if you turn up the love, if you like, by triggering oxytocin release in the brain, you turn down aggression. And so I have very little to do with the company, but they're running that trial at the moment in Sydney, and they're recruiting at the moment for people who have loved ones who are agitated and with their dementia. And we're very hopeful that KNX 100 might succeed as a novel therapeutic for that indication. If it doesn't succeed, I think there's something to be said for low-dose THC and a couple of other molecules that are coming through the Lambert pipeline that may have these effects.
Fascinating. Now, in terms of THC, just the old Delta-9 THC, the old favorite, what impact does that have on the brain? Like, why does it make it feel like a lot of people, feel good? Where is it working? Why is it working? Why do people take THC?
It's a really, really good question. And the lazy answer is that it releases dopamine. So,
But in terms of the brain, what parts of the brain, are really activated or impacted by THC?
Well, they talk a lot about the nucleus accumbens. And again, at kind of kindy neuroscience level.
Please, that's where we're at.
And I call it lazy kindy neuroscience, but sometimes it's very important to have an explanatory principle that's straightforward. But there is a structure called the nucleus accumbens, and just about every drug that has addictive properties, as well as a whole range of natural rewards like social behavior, sexual behavior, food, drink, all the rest of it. It all seems to activate the nucleus accumbens. So a lazy kindy view of
where is that in the brain?
It's in your ventral striatum, so it's in the basal ganglia. It's kind of buried quite deep under the prefrontal cortex, in the depths of the brain. Occasionally, they'll stick an electrode down there, with human beings for whatever reason, for neurological interventions, and you can, stimulate down there and get interesting effects. But the release of dopamine in the nucleus accumbens seems to be a kind of common denominator with a lot of things that are rewarding, and THC certainly does that. But it's a lot more complicated than that. I think the release of endocannabinoids in specific brain regions also are heavily involved in rewards and social rewards as well. And there's a bit of data on that anandamide endocannabinoid has a kind of preferential circuit within the nucleus accumbens that's released during social behavior and contributes towards social reward. And certainly, a light dusting of cannabis can really bring out a social occasion. Too much, you can have the opposite effect, and you become very introverted and withdrawn and socially anxious. But I think this kind of low-dose pro-social effect of THC probably involves that endocannabinoid circuit in the nucleus accumbens. But as I said earlier, these CB1 receptors are everywhere. So the munchies, that's happening in your hypothalamus, the mental clouding is probably happening at the hippocampus and prefrontal cortex. And, a good friend of mine was once in a pub in Canada, and a guy came around with a syringe, just a 1 ml syringe of oil, and said, "You guys interested in this?" I said, "No, I'll pass." But my friend was feeling very extrovert and took the whole 1 ml syringe, which we later worked out probably had about 700 milligrams of THC in it, or 70 times the usual dose.
And how was his conversation after that?
Well, he was basically in bed for the next 3 days. And the really interesting thing was, you talked about Parkinson's disease earlier. He was quite frankly Parkinsonian. He could barely move. And we see this in rats when we give them high doses of THC. they exhibit what's called catalepsy. And it's a sort of waxy immobility where you can mold them into whatever shape you like, and they just stay in that particular position.
Waxy immobility.
And so my friend...
Sounds like a good name for a jazz album.
Actually isn't. So I'll write that one down.
Or Stoned Goat, or one of those.
So my point is that
Yeah.
CB1 is really important with movement as well. So if you overstimulate CB1 in the striatum, you can actually cause a Parkinsonian like effect, which I thought was quite interesting.
So, look, because a big issue that we've got, and it's where policy, politics, and the science is converging, is impairment.
Yes.
And what's your view? Like, when do we become, like, what is impairment? When do we become impaired? Can we measure it, like, or is it going to be different for every single person? So, like, let's talk about impairment. Why do we become impaired? I think that's what you're talking about. And how do we measure it? And what does it mean when we say that someone on cannabis is impaired? How are they impaired?
Well, it's a really complicated issue, and one that's taken a fair chunk of the last 5 years of my life is actually working in the impairment space. I never thought I'd become a driving researcher. I never thought I'd become an expert witness in cases to do with impairment. I never thought I'd be working with mining companies and transportation companies around this issue. And also...
Because it's come to the fore, hasn't it, Ian? Because medicinal cannabis has been legalized in Australia. It's been wildly popular. It's sort of tipping over into, recreational cannabis, in some areas, and I call it relaxational cannabis, where it is people taking it for both for pleasurable purposes, but also medicinal purposes. So policymakers have to turn their attention to how we deal with these people who are taking this cannabis in workplaces, on roads, in society generally.
Employers have a very difficult issue to deal with. Maybe I can best illustrate it with an example. So I got called in to give evidence in a case where a union had a member who was working on a big nickel mine in WA. The guy had Crohn's disease. He'd tried every available prescription medication. Nothing helped, really interfering with his sleep because he would have pain and cramps all through the night. I wasn't a cannabis user, but it was put to him by a friend that maybe medicinal cannabis could help. He tried it, vaping a very small amount of THC containing flower before bed every night, completely transformed his life. Symptoms disappeared, slept like a baby, reported to the mine site the next morning, and had to, like a good citizen, disclose to his employer that he was likely to fail a urinary drug test that was mandatory for all employees. Now, we'd done all the maths on the duration of impairment. I work with a wonderful scientist called Dr. Danielle McCartney, and she's an absolute whiz in this area. And she got every study that had ever been done on cannabis-induced impairment and concluded that with inhaled cannabis, you're very unlikely to show any impairment 8 hours after use, even with quite a high dose of THC.
Even if you're a novel user?
Well, this is it. The data actually refer mostly to novel and occasional users. When you get to people that are using daily, impairment becomes a lot less. They become tolerant to the impairing effects. So that 6 to 8 hours is the worst case scenario for someone who's taken a hefty dose of THC and is relatively cannabis naive. When you get into patients, much less likely they'll be impaired. There will be some impairment, but it's less likely to be of that kind of duration. So anyway, we were able to marshal all that available evidence, published a paper that's been very widely cited all around the world. I was involved in a couple of test cases in Canada, as well in the transportation industry around the same issue. But the miner in WA, we were able to write that report and say there's very, very little chance that he's going to be impaired. Mining company said, we don't care, we're going to fire him anyway because he's breached our drug requirements or he's in breach of contract. So we actually did an interesting thing. We grabbed him and we hired a sleep lab at the University of Western Australia, and he came in to do 2 nights one night where he had his medication as normal, the other night where he didn't have his medication. And we did every possible cognitive test the next morning to look at his cognitive function and how he felt. He felt much better the day after cannabis compared to not having cannabis, but there was no difference whatsoever in his cognitive function. There was no sign whatsoever of impairment. So I think that ended up going to the Human Rights Commission, that particular case. And he was going to be reinstated, but at that time, the arse fell out of the nickel industry worldwide and the mine closed. So he wasn't able to be restored to his job. Unfortunately, I understand he's working at another mine. But that's a good example of how you can use science to actually change employers' attitudes and employers' knowledge in this particular space. And I've been working with a number of coal mines up in Queensland recently about the same issue. And the employers just want to do the right thing. In my experience, it's not an anti-drug, draconian approach. They obviously don't want impaired people on their mine site, be it alcohol, meth, or cannabis.
Or also fatigue.
Or fatigue, that's right.
Because if someone's having their cannabis, like I take medicinal cannabis in the evening, so I get sciatica. And I wake up during the night with just these, this syndrome of just, this irritation in my leg. And it wakes me up 3 or 4 times, interrupts my sleep. And I wake up in the morning, I think impaired, cranky, not functioning as well. If I take a couple of drops of cannabis, sleep like a baby, don't wake up, feel so much better, perform so much better the next day.
We hear this all the time, and these are the medical legal cases where we go into bat, often in conjunction with the mining unions, or in the case of Canada, it was the transportation unions with the Toronto Transit Authority and a couple of other cases there as well. But there's nothing to be frightened of. In a way, if you look at the example of the roads, the main risk factors in the roads don't include cannabis. It includes people who are greater than 85 years old and people that are under 25 years old. Includes people that are drunk, obviously, and people that speed and people that don't get enough sleep. These are the main risk factors when it comes to cannabis.
Road condition.
Yes, road condition as well. With cannabis, it's actually really difficult to show anywhere in the stats that there's a major issue that we should be concerned about.
That's really that's fascinating. What about if it was from a policymaker's point of view? If it was put to you, what would be your view if someone said, "Look, we'll allow medicinal cannabis patients to drive on the road if they're not impaired. We'll put in a buffer, which is, their doctor says, look, you're a novel user, so you're a naive user, so don't drive for 4 to 6 hours." What about the issue of then mixing it with, say, alcohol? Yeah. Should we have zero blood alcohol? Because there's an entourage effect there. What about other medications? And of course, obviously we don't want people taking other illicit drugs. But what about the issue of blood alcohol in particular? Should we say, look, you're a medicinal cannabis patient, you can drive if you're not impaired, but zero blood alcohol?
I think we need to put some guardrails in place. I mean, the alcohol one, I think, probably could be managed at, say, 0.02 rather than 0.05, and that's the approach in certain Canadian jurisdictions, that you just drop that alcohol limit. It's not completely verboten, but there's a limit. The other thing I would highlight is probably 25 and younger. I'm probably not comfortable with combining the folly of youth with a large dose of THC on the roads. The other thing I would insist on is a fairly decent driving history. So, if someone's lost their license 5 times and is a serial offender, I think the privilege of having THC on board is one that probably shouldn't be afforded to them. And I'd also look at the elderly as well. So, it's really just a case of risk management and risk assessment in terms of not multiplying the number of risk factors beyond a reasonable amount. But in terms of your average driver who's got a script for medicinal cannabis, let's just do what Tasmania has done all those years and what Victoria is now doing. And hopefully after the meeting of the the drug summit, or was it the drug summit?
Yeah, the drug summit was
Yeah.
recommended.
It was recommended. Hopefully we'll have the same thing in New South Wales soon.
We have some trials going on in Victoria. There's some research coming out of Victoria. What are we learning about what happens to people if they are, have taken medicinal cannabis and there is that little bit of impairment? Because with alcohol, we know that people become sort of they don't perceive risk as much, and it increases risk taking behaviours. What happens if someone is mildly impaired on cannabis? What do they do?
Yeah, we'll always have a laugh with David Edershank, your comrade down in Victoria and legalized cannabis, and we talk about this quite a lot. We did the studies back in 2020 or thereabouts, and they're running a trial down there, and it's Tom Arkell, the former PhD of mine and a good friend, and he'll run a fantastic trial. But we sort of know the answer already, and governments do this kind of thing when they have difficult decisions to make. They commission a very complicated inquiry or experiment and spend millions of dollars to kind of put it on the shelf for a bit longer.
Kick the can down the road.
Exactly right. So, Tom, when he was my PhD student, we did a wonderful study in Maastricht in the Netherlands, where we got people to vaporize cannabis, and they went for a 100-kilometer drive in a dual control Volkswagen. So we could, if anything really bad happened, the driving instructor could leap in with his controls and save the day, but nothing bad happened. And these were occasional cannabis users. They felt quite stoned. They weaved around a little bit more in their lane, and this is
they felt a lot more impaired than they actually were.
Yes, there was that. There was that too. Some of them didn't actually want to drive.
They wanted to go and have a cup of tea, and
they wanted to have a donut and watch some cartoons. So, but we did that study, and it got published in a very prestigious journal, the Journal of the American Medical Association. They thought it was fantastic. We showed, by the way, that CBD didn't impair at all. And that was important, because I remember going in the early days of medicinal cannabis to meetings with New South Wales Health, where they were saying, well, people mustn't drive with CBD on board either, because that can intoxicate. So we're able to set that straight. But basically, they weaved a little bit more. They looked like someone that was on about 0.04 of blood alcohol concentration. But it's not equivalent. That's just in terms of weaving. There's other behaviors that are very distinct for alcohol versus cannabis. We know that cannabis drivers tend to drive more slowly and leave a bigger distance between them and the car in front. That's been shown in many, many different studies. So it's almost like they recognize their impairment and they adjust for that impairment by driving more cautiously. And we see that over and over and over. Whereas with alcohol, it's a disinhibitor, and if you're not careful, you drive like an idiot and take far too many risks, believing that you're a much better driver than you actually are.
Well, that's fascinating. Now, looking forward, Ian, what's the future hold for the Lambert Initiative, and what do you see being the big issues in terms of and developments in the cannabis space, medicinal cannabis space, going forward?
Well, I think it's really interesting from a policy perspective that Australia seems to have stumbled into a situation where we're actually doing quite well in terms of supplying cannabis products to patients. We have more than 1,200 products available. We have more than 1 million patients. Most people can access whatever they want through telehealth and mail order. So we have a very streamlined process. If you know how to work that process, it's actually fairly trivial to get medicinal cannabis. And I think that's a really good thing. I mean, in the early days of Lambert, 2015, 16, 17, we knew just about every patient in Australia, because there was only about 20 of them, and it was almost impossible to get hold of medicinal cannabis. So we've definitely gone from famine to feast. And I think we should be really proud of the system that has these checks and balances, and you have to see a medical profession. What's interesting for me is to ask whether that's enough for non-medical cannabis, because we know that, I would guess maybe 20% of people getting prescriptions are doing it mostly for entertainment purposes rather than because of their back pain or their anxiety. So we have this kind of leakage, if you like, into the recce market. And, doctors probably are not so keen about prescribing cannabis for entertainment purposes, but they're doing it anyway. And it's probably quite good for people who are getting entertainment cannabis to speak to a doctor, just to check in about their general health and make sure that they don't have a family history of schizophrenia or bipolar disorder, and that there's not going to be any adverse interactions with other medications that they're on. So I actually quite like the current system, even as a recreational system, which is somewhat heretical because the medical profession probably aren't that keen on it. And also because politicians such as yourself are working really hard on trying to develop models for non-medical cannabis availability.
So what you're saying is basically having that framework, where you still talk to a health professional about something that's recreational is a good framework. Because I wonder how you would going to a doctor and saying, I'm thinking about taking up drinking whiskey, what they would say,
They'd probably say, well, try Sullivan's Cove. It's an excellent Tasmanian whiskey, which it's only $700 a bottle, but it's worth it.
It's just boiled Cascade Pale Ale. They just, I digress, but I did do a distillery course at one point, and the old distiller said, I'll let you in on the secret. I'm just an old beer boiler. That's what he said. He said, we just get Cascade Pale Ale, they brew it up, we get a tanker of it over, and basically just boil it.
That's not Sullivan's Cove, is it?
That's Sullivan's Cove.
Oh, my goodness.
And then they sell it for like $30,000 a bottle to Japanese businessmen.
Oh,
there's a process they go through. But it's just, that's how he called himself. We're just beer boilers.
Well, the French Oak Cask won the World Whiskey Award in 2015.
Amazing whiskey. It's beautiful whiskey and good beer too. But
Cascade Pale Ale is just about my favorite beer.
Yeah, that's
fantastic.
right. I've watched them make it, and they're great big still. It's absolutely fantastic. I digress.
We do digress.
We do digress. But the framework that we have for quality assurance in Australia,
yes.
That framework in terms of talking to a health professional is important. One of the sort of the stereotype, the trope that's rolled out again and again with cannabis is that we'll see like an epidemic of mental health problems if we allow people to use cannabis. It'll lead to psychosis in young people and, activating, exciting schizophrenia in young people and other people. What's your response to that?
Yes, so I think there was another really interesting development in Australia, as well as the kind of leakage into the recce market of prescribed cannabis, which is great. There's also what happened in the ACT, where they changed the law in 2020 to let people cultivate their own cannabis at home. And I very much think this is something we can roll out throughout Australia into all the different jurisdictions. And we did a very innovative study called the CANAC study, led by Scylla Zhu and Izzy Lavender and the Lambert team, and talked to 311 cultivators down in the ACT, and also analysed their cannabis, which was not the best weed, actually. It was only 9% THC, so they've got a bit of learning to get up to the...
Maybe that's how they like it.
Exactly.
Well, they're pretty middle class down there, pretty reserved down in the ACT.
I agree. I do have concerns that there's this arms race with THC up to 25, 30%.
31%.
31%. It's nuts. And you're going to end up with people getting a lot more intoxicated than they need to or even want to with these sort of strengths. So I would like to see, we did all the analysis of the ACT cultivators. A lot of them were growing for other people. There was altruistic cannabis being grown a lot for medical purposes. A lot of people growing just for the hell of it because they enjoyed it and they were allowed to do it. They enjoyed the process. But, we looked high and wide through all sorts of stats to try and show that there was some harm that had arisen from allowing this home cultivation. And there's nothing. There's nothing on the road. There's nothing in terms of mental health admissions. There's nothing in terms of emergency episodes involving cannabis. You can't find anything in Canberra that suggests that particular move in terms of legalizing cultivation had any adverse effects whatsoever. So let's use that evidence and roll it out everywhere else. And not everyone's going to have the premises where they can grow cannabis. Not everyone's got a garden, particularly young people who can't afford a house. So there's issues like that, but maybe cannabis cultivation clubs, maybe there's common, public ground where cultivation could take place, like vegetable allotments or whatever. There are workarounds for that. I think that's a healthy approach, but also to allow people to get non-medical cannabis on prescription is another thing that would be great to see.
Ian, fascinating. I could listen to you forever. You are not only an amazing researcher, you're an incredible communicator, and you've educated so many students, but also politicians and the populace generally. And we have been well served by your knowledge, your capacity to turn these incredibly complex neuropsychopharmacological processes into concepts and that we can understand and build this body of evidence that is guiding this responsible change. So I thank you very much for the work you've done at the Lambert Initiative, you've done in the community in this area. And I look forward to living to 178 with you, not listening to jazz, maybe some of your country music and your punk music, and having a donut and some cartoons in 2115 when we're happy and healthy and dementia-free, mate. Thank you very much for the work you do and for coming into the weeds.
Well, thank you, Jeremy. If I could just say a couple more things, I realize I've probably run out of words, but
I doubt it.
I'd like to acknowledge the more than 100 fellow scientists, staff, students, admin staff that have allowed the Lambert Initiative to prosper. And I'm really just a reflection of their hard work and all the great work that they've done. I'm incredibly proud of what we've achieved. So thanks to them. And of course, going right back to the Lambert family and their generosity. And, I hope that we've managed to dignify their generosity and their great gift with some great research outcomes.
You have, mate. You've been absolutely fantastic. And I think they'd be very proud of the work that you've done. So thank you very much to you and your team and to the Lamberts for what they've done to help transform this country and our understanding of this amazing plant. Thanks very much, Ian.
Thank you, Jeremy.